Okay, that is about reversible and irreversible process. What is a reversible process? Reversible process is a process that can be reversed without leaving any trace on the surrounding, and both system and surrounding return to their initial state at the end of the reverse process. But for irreversible process, it's a process that is not reversible. Okay, all the processes occurring in nature are reversible. So usually we wouldn't find any reversible in the real life. But why are we interested in a reversible process? One is because they are easy to analyze, and two is because they serve as idealized models, the theoretical limits in which actual process can be compared. So usually reversible process have higher efficiency or maybe 100% efficiency, but in real life we don't have reversible process. Usually we have irreversible process. So reversible process can be viewed as theoretical limit for the corresponding irreversible one. We try to approximate reversible process. So reversible process deliver most work and consume less work. For example, there's a frictionless pendulum here. Usually it will come and go backwards. If you say it's a reversible process, the position here and the position here will always be constant. It will come 1 to 2 at the same point every time it is finish a cycle. But in a real life, this won't happen. Usually it will come lower point and lower point until it's come to complete stop. Okay. Reversible process, usually we said process don't have any losses such as friction and unrestrained expansion of gases, heat transfer to infinite temperature difference, mixing with two different substances, any deviation from quasi-static process. And reversible process, as I said just now, deliver the most and consume less work. You see here in the slow reversible process and a fast slow reversible process and fast irreversible process. So when we do expansion and compression slowly, it will be more to reversible process because it use the most and consume less work. But if we do this faster expansion and compression, we do it in a high speed, so this will become more towards irreversible process, so the work done will be higher. So this is not efficient. So if you say here work for expansion and compression is nearly equal, whereas if irreversible process, the work of expansion and compression is have a big difference or gap. Okay, there's a very famous reversible process known as Carnot cycle. It is named for French engineer. That's the name is Nicolas de Carnot. He lived in 1769 to 1832. He's the one who introduced Carnot cycle. This is a very important or very famous example of reversible process. The composed of this cycle have 4 reversible processes. 2 is adiabatic, which is no heat transfer, and the other 2 cycle or process is the isothermal heat transfer, that is process with same temperature. We will learn more detail on part 5 later on for the Carnot cycle. Okay, Carnot heat engine is the most efficient of all heat engine operating between the same high and low temperature reservoir. So the efficiency of the Carnot engine for a reversible cycle, the amount of heat transfer is proportional to the temperature of the reservoir. So the higher the temperature difference is, the higher the efficiency is. So this is only true for a reversible and reversible cases. So it is same in the same as temperature difference. So the higher the temperature difference, the higher the efficiency is. And for the COP of heat engine, heat pump in reversible, refrigerated in reversible will be the same as the temperature difference. And this is only true for the reversible case. Usually in irreversible case, this won't be the same. So no heat engine can have higher efficiency than a reversible heat engine operating between the 2 reservoirs. So how do reversible and real system compare? You can ask your question, how do you increase the COP of a Carnot refrigerator or heat pump? That is if it is reversible. And how about the actual one, which is not reversible? So the efficiency of a reversible heat engine such as Carnot engine is always higher than the real engine, and the COP of reversible heat pump is always higher than the real pump. So with the refrigerator, the reversible one will be higher COP than the real refrigerator because the real one is not reversible. That's all.